Alright, so I'm going to demonstrate today the titration of vinegar lab. The objective of this lab is to learn how titration can be used to determine the amount of moles in an acid or a base. So let's go ahead and get started with this lab. The very first thing that you want to do is go ahead and calibrate. You want to determine how many drops of water are in 1 milliliter. So I'm going to go ahead and use my pipette and pull up to the 1 milliliter mark on my pipette, pull it out of the water. Okay, and then I'm going to go ahead and drop into my graduated cylinder, and I'm going to go ahead and count until I hit the 1 milliliter mark. So 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So 21 drops. I'm going to go ahead and check my graduated cylinder, and I'm at 1 milliliter. So 21 drops. I'm going to go ahead and mark that down in my lab notebook. So 21 drops equals 1 milliliter. Alright, I'm going to go ahead and weigh my graduated cylinder, and then I'm going to zero the scale, and I'm going to add 1.6 milliliters of vinegar, and make sure that you read to the bottom of the meniscus. And that should do it. And it looks like 1.60 grams of vinegar. Alright, for my next step, I'm going to go ahead and add the 1.6 milliliters of vinegar. Make sure I get every last drop out. And to that, I'm going to add 25 milliliters of distilled water. Once I've done that, I'm going to go ahead and drop in 3 to 4 drops of phenolphthalein, which phenolphthalein is an indicator that turns pink in the presence of a base. Alright, so what I have in here is vinegar, water, and phenolphthalein, and I'm going to add a base. In this case, I'm going to add 1 molar NaCl, NaCH, sodium hydroxide, drop by drop to my vinegar. Once the phenolphthalein turns pink, I'll know that my liquid has turned into a base. So I'm going to go ahead and pull up some sodium hydroxide. I'm going to add drop by drop and count my drops. So 1 and swirl, 2 and swirl, 3, swirl, 4, swirl, 5, swirl, 6, swirl, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Oop, that one just turned pink, so just one more. 29, 30, and the pink must stay for 30 seconds. 31, so it looks like one more drop. 32. Nice pink color. Is it going to stay for 30 seconds? I believe so. So we're going to record 32 drops, but because we have pink, it means we have a base, so we have to subtract 1 drop for our equilibrium point. So we added 31 drops of sodium hydroxide. And go ahead and record that in your lab notebook. All right, let's go ahead and convert our 32 drops of sodium hydroxide into milliliters. So I take 32 drops, and previously with your calibration you determined that 1 milliliter is 21 drops. And so that will give you 1.52 milliliters. Okay, go ahead and take your 1.52 milliliters and turn that into liters by dividing by 1,000, or just moving your decimal to the left 3 times. All right, now I'm going to go ahead and convert my milliliters and my molarity using my molarity formula into moles. So molarity equals moles over liter. So if we looked at the package, our molarity was 1 molarity NaOH. That equals X moles over my liters. So now I do some algebra. I multiply this number on both sides, and so I should have 0.00152 moles of sodium hydroxide. Okay, my next step is to use a mole to mole ratio to convert moles of sodium hydroxide to acetic acid. And you remember from the stoichiometry unit, the only way to do that is to use a balanced equation. So here's my balanced equation for acetic acid plus sodium hydroxide, and we'll notice that it's a 1-to-1 ratio. So 0.0015 moles of sodium hydroxide is equal to 0.0015 moles of acetic acid, because the ratio is a 1-to-1 ratio. Alright, my next step is to go ahead and convert my moles of acetic acid into grams. The only way to convert moles to grams is to use formula mass. So I take my 0.0015 moles of acetic acid and I multiply it by the formula mass for acetic acid, which is 60.1. That is going to go ahead and give me 0.09 grams of acetic acid. My last step is to calculate percent by mass, and I use the formula percent mass is equal to the mass of acetic acid over the mass of the vinegar. And if you remember, we measured this as 1.6 grams on the scale. So I take my 0.09, divide it by 0.06, multiply it by 100, and I get 5.6%. So does 5.6% acetic acid and vinegar match the 5% commercially stated value? And for high school chemistry, it was close enough. Well done.